Okay, I want to keep going over how to use Desmos to help here on this MCA. And so far we've just been graphing equations, but now we're going to do points. So find the coordinates of the midpoint of a line that segments, the coordinates of the midpoint of a line segment are that, and one endpoint is this. What are the coordinates of the other endpoint? Okay, so just roughly speaking, right, they give us the midpoint, that's like this one, and then they give us one of the endpoints, and then our job, sorry this is looking kind of terrible, but our job is to find the coordinates of the other endpoint over here. So like what are the x, y here? And I'm just going to do it visually with Desmos. So basically I'm going to type those points in, kind of like you see them there, -7, 3. Let's get back in here. So just type it like -7, comma, 3, and you can see the points show up there. You can put a little label on it if you want, which is kind of nice. And then -3 and 1. And again, these are all taken from previous tests that I think are pretty easy if you know how to use the Desmos machine. Okay, so basically those are the 2 points. So that means the other point has to be like right about here, like right up in there somewhere. So I'm just going to type in the answer choices and figure out which one works. Okay, so -17, 7. -17, 7. That's way off. That's no good. All right, let's try -11 and 5. Okay, and that looks pretty darn good. That's going to be my winner, I'm guessing. But I'm going to check the other ones just to see if there's any ones that are close to that. -5 and 2. There, that one's in the middle where it shouldn't be, right? It should be an endpoint. That's in the middle, so that's not right. And -4, 2. Kind of the same thing. That's between them, so that's no good. So the one that worked was this one. And again, it's the endpoint on the other side of it. So just to show you again what it looks like, -11, 5. Now, this is the midpoint, there's an endpoint, and this would be the other endpoint if you extended the line out so that these segments would be the same. Okay, so far we've done like one equation, but now I want to show you a couple systems and how Desmos can help with that. The only thing here is you need to write the equations first, and then solve them. We're going to solve them using Desmos. So see if you can pause the video and write 2 equations here. I think your variables are like how many large cups, how many regular cups you get, and how many large cups you get. Okay, so again, here's your 2 variables. Pause the video, give it a shot. Okay, so you're going to have 2 equations. One involving the money, which is $1 per regular cup plus $1.50 for large cups, and that has to be $6. Right? If we spend a total of $6, then it was $1 times however many of these cups, and $1.50 times however many of those cups. Okay, and then our other equation is just the number of cups. And I know that because we have a total of 5 cups. So the number of cups has to be 5. So if you add the regular cups plus the large cups, that has to be 5 because we got 5 total. Okay, and so normally when you solve a system here, you got to like, say, multiply this equation by -1 and then stack it up underneath here and then add them up to get the x's to disappear. Desmos makes this magical. You can literally just type them in the way they are now and find where they cross, and that's going to be your answer. So let's just go to our Desmos machine and type both of these in and delete this old stuff. So I think they were 1x plus 1.5y equals $6, and x plus y equals 5 total cups. So you can see the 2 graphs, and the point they shade right there is 3, 2. So you literally just graph it, click on it, and you can see that this works, right? Like 3 plus 2 is 5. And then if you go here, it should also work. This would be 3 plus 1.5 times 2, which would also be 3. So you'd have 3 plus 3 equals 6. Right? So you can know that this has to be the right point. Maybe I'll write that out on the other screen. But if you put them in, it'll work for both. So going back to our choice here, our answer was x, 3, and y, 2. Here's what the check would look like again. Put in 3, put in 3 for x and 2 for y, and you get 3 plus 3 equals 6, so that's good. And then if you check the other one, it would just be 3 plus 2 does equal 5. So you can see that that solution works for both of the equations. And again, Desmos makes that really nice because you can just type it in. You don't have to solve for y, just type it in and click on where it crosses. All right, so let's do, you can do systems of inequalities too. And I just want to make sure you knew how to do this on the Desmos. And when we did lines, it's just where the points cross. When it's inequalities, you like shade above or below the line. And then your solutions are where it overlaps. So Desmos, you can do this. You just got to know how to find these inequality symbols. So if you want to practice typing them in here with me, it's just y, and then the symbols are down here. So I'm going to do y less than x plus 1, and you can see it makes a nice graph shaded below. So just to review this anyways, it's a dotted line because there's no equal to here. If it wasn't equal to, it would be a solid line. And then you shade below because the mouth is facing away from y, so y is little, so you shade below. So that's what you're seeing there. And then let's do the other one. Y less than absolute value again, which is right here, x minus 3 plus 2. Okay, and that one is a V because of the absolute value. It looks like it moved right 3 and up 2. You can see kind of the, well, what did I just do? Oh man. So it's a V shape, dotted because there's no equal to here, and shaded below because the mouth is facing away from y, meaning y is little. So our solutions are all this shaded region down here. Okay, and you can find, like, if you want to find where they cross, you don't really need it here. There's your vertex or whatever, but your solutions are down here. So one possible solution would be like 10, 0, or like 10, 1, or say like 6, negative 2. All of those would be possible solutions. Okay, so if you had to find some solutions, we could just list a bunch of them here. I think we had 10, 1, and 10, 0. And then the other one was like 6 and minus 2. And those are all possible solutions to that system, just where they overlap. And again, if you know how to graph that in Desmos, that's a pretty easy question. My guess is you'd have to just match up the graph on the MCA, so you could just type it in and then look at which graph matches it. Okay, another system one where we want to find their shading that overlaps, but what's different here are these are special lines. And again, these are hard to remember, but with Desmos, you don't have to remember it, right? You just got to type them in. A Y line actually goes this way. It goes through Y4, it's solid, and then you shade above it because the mouth is eating Y. And then an X line goes up and down. So the X line is going to start at -1. It's going to be dashed. And then we're less than -1, so we're going to be this way. So our shading should be right up here. But again, you can do this in Desmos. So just to show you those lines, let's do y greater than or equal to 4. You can see that green line we're shading above there. And then I think it was x and less than 1. No, -1. So you can see that there. And again, this is where our shading overlaps. So one possible solution would be like 10 and -10 for x, and +10 for y. So that'd be one possible solution. Which makes sense, right? 10, if y is 10, that'd be bigger than 4, and -10 is certainly less than -1. So that'd just be one possible answer you see up in the shaded region. Okay, one final question here is Desmos does have a table feature, and it's helpful here because we want to find when is the ball reaches the 5th bounce. So we want to do like x and y, but we really want to know, like, on bounce 5, what is the height y. Okay, so the first piece, we actually have to write the equation, and this is an exponential because it bounces back up 75% of its previous distance. So if you remember exponentials, the general form looks like this, where a is the starting amount, or height in this case, and this is like the number you multiply by, which in this case is actually the percent remaining. So see if you can write the equation quick, and then type it into Desmos. Okay, so our starting amount here is 10, and we have 75% remaining after each bounce. All right, so this is going to be our number of bounces. So we're going to take it 10 and multiply by 0.75 x times. Okay, and again, we want to find out what it'll be on the 5th bounce. So let's load up our Desmos machine here and just type that in. Y equals 10, 0.75 hat thing x. And again, you can get all those keys down here. I'm typing them on my keyboard, but you can certainly use the square thing there. And you can see the graph in the 5th bounce, and we could try to zoom in actually. The 5th bounce looks like it's going to be about 2.3-ish or something like that. But I think there's a way inside of here you can just click create table. And then you can see, well, it doesn't have all the points we need actually. But I'm just going to type in 5 for x, and then it makes a point at 5, and it shows you the number there. So if you need any number, let's look at bounce 6. There's where bounce 6 will be. It's pretty slick, but the one we need is 5. So it looks like 2.373 is going to be our winner. 2.373. All right, and that is an answer choice, so I'm feeling pretty confident that that's what it'll be after the 5th bounce. So again, to get that, it's just you click this little gear up here and hit the table, and then it spits out those points, and then you can add extra x points here if you need, which is kind of slick. So, all right, that's all I got. Thanks for watching, and hopefully it helps with the test.